Hello students, once again welcome to Bholanath Academy. In this video students, we are going to see the chemical reaction of aldehyde and ketone with nucleophiles. Now here students, nucleophile is very important. Now you have aldehyde and ketone in your hand and now you are going to react with nucleophile. So students, first off, what is the nucleophile students? Nucleophile reagent, which nucleo means nucleus loving reagent. That means that will be always negative. Who loves the nucleus, that will always negative. So this is called as nucleophilic reagent. So nucleophilic reagent bring about the reaction by attacking on positively polarized electrophilic nil carbon. Now here students, we are talking about the positively polarized electrophilic carbonyl carbon. So carbon which is having positive charge, that is called as electrophilic carbonyl carbon. Okay students, the carbon which is having positive charge. In aldehyde and ketone, you have electrophilic carbonyl carbon which is always positive. Okay students, here positive word is very important students, and here it is negative. So nucleophilic reagent bring about the reaction by attacking on positively polarized electrophilic carbonyl carbon in aldehyde and ketone. So students, aldehyde and ketone both are having electrophilic carbonyl carbon which is positive. So this nucleophile will attack to this positive charge and form the reaction. Okay students, so which type of reaction students? First we are going to see the addition. Because of the nucleophilic reagent, there is addition of hydrogen cyanide. This is hydrogen and this is cyanide. Okay students, so we are going to see the reaction in aldehyde and ketone students. Addition of hydrogen and cyanide. So here students, hydrogen will be positive and cyanide will be negative. Okay students, so this is nucleophile students, cyanide will be nucleophile. Okay students, this cyanide now it will attack to the positively charged carbonyl carbon and form the addition reaction. So first students, we are going to see the reaction with aldehyde. So here students, carbon having 4 valency, 2 valencies occupied by oxygen, other 2 valency, out of these 2 valency students, 1 valency I am replacing with methyl and other is by hydrogen. If it is hydrogen, we call as aldehyde, that is containing 2 carbon, we call as acetaldehyde. This is acetaldehyde. Now what happens students when you add the nucleophile hydrogen cyanide? This is hydrogen cyanide students. Now this hydrogen will be positive and this is what? Negative. Now here students, in carbonyl, this is the carbonyl, this carbon will be partial positive charge and this will be partial negative charge. Now students, this cyanide will attack to this carbon content. This is electrophilic carbon students, we call as electrophilic carbonyl carbon. Now this cyanide will attack, not this hydrogen, mind well students, this in hydrogen cyanide will be the nucleophile. In this molecule students, cyanide will be the nucleophile. It will attack to the electrophilic carbonyl carbon like this students. And what happens students when it will attack, this carbon and oxygen double bond will become single bond like this. It is becoming single bond. Okay students, this will become single bond. So it will form cyanide, they will be added and this hydrogen will go to this point. That means both the whole part of the molecule will be added. That is why it is called as addition reaction. Okay students, both nucleophile is also going to be added and this hydrogen is going to the negative charge. So they will be called as like this students, this hydrogen will go to the oxygen and form OH and your methyl group will be as it is and hydrogen will be as it is, and this is called as acetaldehyde cyanohydrin. Okay students, this is the acetaldehyde. It is a derivative of acetaldehyde, so we call as acetaldehyde containing hydroxyl and cyanide group, we call as cyanohydrin. It is called as cyanohydrin. Okay students, cyanohydrin. So this is addition of hydrogen cyanide to aldehyde. Now students, we are going to see the addition of hydrogen cyanide to ketone. We are going to add the hydrogen cyanide to ketone. Now students, this is the carbonyl. Here two valency is there students. If one valency by methyl group and other is also by methyl, both the valency of this carbonyl is occupied by methyl group, so we call as ketone, and ketone it is a containing 3 carbon, so we call as acetone. This is very important example of ketone students, acetone. Now if you add hydrogen cyanide, what happens students? In hydrogen cyanide, This cyanide will be nucleophile containing negative charge. That is why we call as what? Nucleophile. And this will be positive charge. Now here students, this is the reagent students. This cyanide is nucleophile. It will attack to the negative positive part of the carbonyl, and this oxygen is what? Negative charge. So it will attack to the carbonyl which is positive charge, we call as electrophile. Okay students, electrophilic carbonyl carbon which is positive charge. Now what happens students? Second part of this hydrogen cyanide, that is hydrogen, will go to the oxygen. Now because of this attack students, there is a carbon carbon double bond, carbon and oxygen double bond will becomes carbon oxygen single bond. Okay students, this way students. Now what happens? This cyanide will go here and this hydrogen will go to the oxygen, and your methyl group will be as it is. So it is derivative of acetone, so we call as acetone. Acetone is converted into cyanohydrin by attack of hydrogen cyanide. Addition of sodium bisulphite. Now here students, we are going to see, this is the nucleophile students, sodium sulphite, and this hydrogen will be positive charge. So first we are going to add this sodium bisulphite to aldehyde students. This is the carbonyl, 2 valency, 1 valency by methyl, other by hydrogen. So this is called as acetaldehyde. When added to sodium bisulphite, when added to sodium bisulphide, what happens students? Here this will be hydrogen. This you can also write like this students. This hydrogen will be positive charge and NaHSO₃ will be negative charge. So this hydrogen which is positive charge students, it is going towards the oxygen of the carbonyl. Here students, in carbonyl, this carbon will be partial positive charge and oxygen is partial negative charge. So this proton will go to the oxygen. Now what happens means, this sulfur of the sulphide is going to be attacked to the positive charge carbonyl. Okay students, now what happens students? Because of that, this carbon oxygen bond will break and it will, double bond will become single bond like this. Now what happens students? It will form the hydroxyl group with this hydrogen, and this sulfur of bisulphite, sodium sulphite students, sodium sulphite, where sulfur is negative charge, SO3 Na, will go to the carbonyl group like this students, and your methyl and hydrogen will be as it is. So it will form as a adduct. Okay students, so this is the addition reaction students. Whole part of the molecule is going to be added to the aldehyde. Okay students, and it will form acetaldehyde sodium bisulphite. Okay students, so this way students, hydrogen is going to be added to the oxygen, and this sodium sulphite is going to be added to the carbonyl, positive part of the carbonyl like this students, and it will form the adduct. That adduct name is acetaldehyde sodium bisulphite. It will form the added product that we call as adduct. This whole part of the molecule is going to be added to this acetaldehyde, that is why it is called as adduct. So it is acetaldehyde sodium bisulphite. Very important students, addition reaction of sodium bisulphite. What happens if it is ketone? If we are going to take the ketone, in ketone students, carbonyl, if both the valencies occupied by methyl, we call as ketone. Now which type of ketone containing 3 carbon? It is acetone, or you can say propanone. So it is acetone students, acetone. When added to sodium bisulphite, what happens students? When it is added, sodium bisulphite is added students. Here students, this hydrogen will be positive charge, and this SO3 sodium sulphide, this is sodium sulphide, whole is negative part students. Now what happens students? This is the nucleophile. Here it will be act as a nucleophile. Now this nucleophile will attack to the positive part of the carbonyl, and this is the negative part of the oxygen, is negative part. Now what happens students? This hydrogen will attack to the oxygen. So the whole molecule is added students. Because of this addition students, this carbon oxygen double bond will become single bond, like this students. Now this, when hydrogen will go, it will form hydroxyl group, and here sulfur, sodium sulfide, sulfur is going to be react, and it is added to SO3 Na, and your methyl group will be as it is. So this way students, acetone when containing hydroxyl and this sodium sulfide group we call as acetone sodium sulfide adduct. So it will form the adduct students. The adduct name will be, it is added, whole part of the molecule is added, it is called as sodium sulfide adduct. So which type of whole molecule is added and it is formed the adduct name will be acetone sodium sulfide. So when it is added to acetone, it is called as acetone sodium sulfide. Third type of addition of reaction with aldehyde and ketone that we are going to see, that is called as alcohols. In alcohol issuance we are going to represent ROH. Here students, this is the alkoxy group students. Okay students, this alkoxy is negative charge and this hydrogen is positive charge. The alkoxy will be act as a nucleophile. It will be act as a nucleophile. So here students, we have aldehyde and we are going to add the alcohols. Now what happens students, when you take the example students, first example of aldehyde we are going to take students, that is acetaldehyde, carbonyl students, 2 valency, 1 valency by methyl, other by hydrogen. This hydrogen when added to directly attached to the carbonyl carbon we call as aldehyde. Now containing 2 carbon we call as acetaldehyde. This is acetaldehyde. Now when you take the alcohol students, now instead of alcohol I am taking methanol. Yeah, you can say ethanol. If you take the ethanol students, addition of ethanol, so here students we can also write like this, C2H5OH. Here this is ethoxy group students. This is ethoxy will be nucleophile. It will be act as a nucleophile, negative charge, and this hydrogen will be positive charge. Okay students, now whole molecule is going to be added. Now what happens students, since alcohol is there students, there is a reversible reaction will take place students. In presence of dry HCl, this addition reaction will take place in presence of dry HCl and dilute HCl. Okay students, now what, there is a reversible reaction students. What happens students, this is unstable product will form, that is why it is reversible. So what happens students, this carbon oxygen bond will become single bond like this students. Okay students, now this ethoxy is going to be attack with positive part of the carbonyl and it is oxygen is negative part. Now this hydrogen will go and it is added to the oxygen which is negative charge. So addition reaction will take place students. Now here it will form C2H5, ethoxy will be added like this, and your methyl will be like this. So it will form hemiacetals, which is unstable. This is very unstable product students. Now because of this unstable students, it is unstable students. This instability I can show like this. This is unstable. So this is the formation of hemiacetal. This is the first step. Now in second step students, what happens, this hemiacetal will accept one more molecule of ethanol. Why it is unstable? Because it is containing hydroxy as well as ethoxy group, so it is unstable. So it will, in second step students, C2H5 ethanol. Here this is ethoxy students. This is ethoxy which is negative charge and this hydrogen will be positive charge. Now what happens students, now in presence of dry HCl and dilute HCl students, so this hydroxy now combines with hydrogen and it will form the water molecules. There is elimination of water molecules and this ethoxy is going to be added like this students. So this will form OC2H5 and it is as it is. So here 2 ethoxy group is going to be added to this aldehyde, acetaldehyde. This is your acetaldehyde students, and 2 ethoxy group is there. So this is stable product students. Now it is stable and it is called as 1,1-diethoxyethane. So this is the first carbon and this is second carbon. So at carbon number 1 you have 2 ethoxy group, so it is called as, so it is 1,1-diethoxyethane. This is the stable product students. So this way students, you have got 1,1-diethoxyethane. This is also called as acetal. Going to take that is example of ketone. So students, carbonyl or 2 valencies occupied by methyl, both the valencies occupied by methyl. So this is the ketone students example we call as acetone. What happens students when you add 1,2-diol, that is here students this type of hydroxy group you are going to add. This is the alcohol students. This is the alcohol students, that is ethane 1,2-diol. This is ethane 1,2-diol. Okay students, so this is the alcohol students we are going to add. So this alcohol will always is going to be added to this acetone. Okay students, now what happens students, in presence of HCl gas and dilute HCl, this ethane 1,2-diol will added to acetone by elimination of water molecules. It is going to be added. So what happens students, this will be these two hydrogen which is positive charge. Here this carbon will be positive and the oxygen will be negative. Okay students, so this positive part of hydrogen is going to be react with the oxygen and it will form the water molecules. Water is now what happens students, this carbon oxygen which double bond will break and it will form the bond like this. Methyl group will be as it is, and this oxygen of ethoxy will be added like this, and it will form cyclic ketone. So this is the product students that is called as ketone. In ketone students, only ethane 1,2-diol is going to be added to the acetone and it will form the cyclic ketone like this, that is called as ethylene glycol ketone. To aldehyde, addition of Grignard reagent to aldehyde and ketone. You have aldehyde and ketone. What happens students when you add Grignard reagent to this aldehyde and ketone? So here students, first we are going to add Grignard reagent to aldehyde. Students, you have aldehyde carbonyl, 2 valency, 1 valency by methyl, other by hydrogen, so it is called as acetaldehyde. Now in this acetaldehyde, this will be carbon will be partial positive charge and this will be partial negative charge students. Now when you add Grignard reagent students, that is we call as RMgX. So instead of R students, I am taking methyl and magnesium. Instead of halogen, we are going to take the iodine. So it is methyl magnesium iodide. This addition reaction will always take place in presence of dry ether. So what happens students, this magnesium will be partial positive charge and they both are partial negative charge. Because of this students, this Grignard reagent is very reactive. Now what happens students, this methyl is going to be added to the positive part of the carbonyl and methyl magnesium. This magnesium halide is going to be added to the oxygen. So this way students, it will attack, there will be this molecule is added to this aldehyde. So first students, it will form that, because of that students, this is the carbon oxygen double bond will become single bond like this, and your oxygen is added like this, and your methyl is going to be added. So this way students, methyl and hydrogen will be as it is, and it is unstable product students. So we are going to keep inside this box. It's complex students. So what happens students, this complex then react with acidic water, H2O, dilute HCl students. What happens students, this is dilute HCl is here, the water is nothing but OH. Okay students, this will be positive and this hydroxyl will be negative. So what happens students, it is negative part of hydroxyl will combines with magnesium, it will break students and it will form, so it will form CH3, COH and CH3, isopropyl alcohol. There is a formation of isopropyl alcohol, and here this will be added to hydroxyl group and it will form the magnesium hydroxyl of water will be added like this. Okay students, this is the alcohol you are getting students, that is isopropyl alcohol. Understanding students, isopropyl containing 3 carbon. Here the 1 carbon is coming from here and it is having 2 carbon, so your compound is having 3 carbon, that is isopropyl alcohol. So this is very important students. This is the ketone students, both the valencies occupied by methyl, so this is called as acetone. What happens students when it is added to methyl magnesium halide in presence of dry ether? So here students, this carbon will be partial positive charge and this oxygen partial negative charge. Here students, this is partial positive and these both are negative charge. Now what happens students, this molecule is going to be added, this methyl magnesium halide, the methyl part is going to be added to this carbon, and this magnesium is added to the oxygen part. So because of that students, carbon oxygen double bond will become single bond like this. So methyl will be as it is. Now what happens students, this methyl is going to be added here and your magnesium will be added to the oxygen like this. And this is unstable students, this is complex unstable. If you add acidic water students, what happens students, here acidic water is nothing but HOH. This hydrogen which is positive charge, this is positive and this is negative, is going to be attached to the oxygen and this will go to the hydroxyl group. So there is a formation of alcohol students, it will form the alcohol. So it is nothing but third butyl alcohol and you are getting magnesium iodide. So this way students, you have got the alcohol, that is tertiary butyl alcohol containing 4 carbon. So students, your product is starting from 3 carbon, that is acetone, and this methyl magnesium having 1 carbon, and your last product is containing 4 carbon, that is tertiary butyl alcohol. So these are the addition reaction we have seen students. Very important in examination, sometimes they may ask like this. So this way students, you have to write in examination, you will get the full marks. If you like my video, please share it, subscribe it. Thank you very much. Have a nice day. God bless.